Hello friends, and welcome back to another episode of Spilling Studio. My name is Sam and I'm a licensed practicing architect, which still feels weird to say. Doing a bunch of practice questions helped me out a bunch when I was studying. So in this video, I've created 7 ARE practice questions designed to help you pass your next exam. There's 1 question per exam topic and a bonus question at the end, so stick around. Starting us off is practice management. Which of the following factors is crucial for ensuring effective project coordination and communication among multidisciplinary teams? Utilizing traditional construction methods, restricting stakeholder involvement, implementing a centralized project management software, avoiding regular project status meetings, or limiting documentation sharing. Feel free to pause here to answer. The answer is implementing a centralized project management software. This is a question that comes down to a few keywords, which are effective project coordination and communication. A lot of the questions in the ARE have hidden gems in the questions that show you what the right answer is. Hopefully this one was kind of easy, since most of these would actually hinder successful coordination. The first option isn't quite positive or negative. Some traditional methods are still used today, like how we number our drawings, the symbols that we use, and so on. However, this option does not specifically address coordination or communication. You could reason this answer to being right, but when you start doing that, that's when you know you have the wrong answers. So many times when I first started out testing, I would get down to 2 answers. I would have one that I was pretty sure was right, but I would argue with myself about how the other one could also be right. When you start doing that, abort. Your initial thought, the one that you are more leaning towards, is probably the right one. I'm not saying don't take your time and consider all your options. Of course, always think through each option carefully, but if you're justifying super hard for one, then that's probably not it. The next one, restricting stakeholder involvement, is never a good thing. They are your client and you want to communicate with them to ensure you're meeting their project goals and needs. Avoiding regular project meetings will have negative effects on communication and coordination. Even with a lot of meetings moving to virtual settings, it's important to have a regularly scheduled meeting, virtual or in person, to keep team members informed, talk about coordination issues, and make sure everyone is progressing on the project. For effective coordination, you have to share documents. We recently finished drawings for a 30,000 square foot building, and there is no way that thing would be standing after construction if we didn't send hundreds of models and PDFs back and forth with our subconsultants and clients. Sharing documents is essential to successful project coordination. And lastly, implementing a centralized project management software will aid in communication and coordination. It provides a place for team members to track progress, manage tasks, share information, and collaborate in real time. We don't use a project management software at my firm, but we're small, about 12 people. We typically use some type of management system through a contractor once a project goes into construction. That's where we go to answer RFIs, review submittals, upload field reports and site photos, and other construction coordination tasks. I do know of a few larger firms that use project management software internally and they enjoy it. Let me know in the comments if your firm uses one, and if so, which platform. Alright, next up is project management. Which phase of a project involves the detailed planning of project scope, objectives, and deliverables? Schematic design, design development, construction documents, the pre-design phase, or post-construction evaluation? Pause here to answer. The answer is pre-design. The phase of detailed planning involving project scope, objectives, and deliverables typically occurs during the pre-design phase. This initial design phase involves establishing the project vision, defining initial requirements, outlining goals, and conceptualizing the project scope. Schematic design is where we get into the first bit of design. It often includes preliminary sketches, rough layouts, models, massing studies, preliminary site plans, initial zoning research, and a general idea of the building structure and building systems. This phase concludes with a design presentation and an approval from the client to move to the next phase. In design development, the initial concepts from schematic design are further redefined, detailed, and developed. Technical aspects, structural systems, and more specific design elements are worked on. During this phase, you will have plans, exterior building elevations, building sections, important major standard details like the wall type, roof type, foundation type, and how those connect together, and any other major feature of the building, like if there's a large shading canopy or an intricate exterior skin, those items will be detailed too. Major structural elements will be implemented and the building systems will be further defined. Depending on your deliverables, this phase may include updated renderings. This phase also concludes with a presentation and the client's approval to move to the next phase. Construction documents is our last drawing phase. It involves creating detailed drawings, specifications, and documents necessary for construction. It's all about producing the final documents needed for the actual building. So all drawings, schedules, details, specs are fully developed and complete. Code requirements are finalized and detailed in the construction drawings. Depending on your contract, you may have one more page flip with your client, and then the drawings would go to permitting for approval to move on to construction. Not provided as an option in this question, but falls between construction documents and post-construction evaluation is construction administration. That phase happens when the building is being built and involves working with the contractor, answering RFIs, reviewing submittals, attending OAC meetings, and conducting site visits. Post-construction evaluation is an additional service and is essentially about reviewing how successful the project was. So you will assess the performance, both how it was constructed and how it was designed, the quality of the work, how occupants feel about the space, and what the client thinks about the project. During this time, any work defects or warranty issues will be addressed, documents will be archived, and the energy and environmental performance data will be reviewed and adjusted. Now on to programming and analysis. During the initial phase of a project, which of the following considerations is crucial for ensuring effective stakeholder engagement? Conducting a detailed site analysis, establishing a realistic project schedule, developing a comprehensive cost estimation, identifying and involving key project stakeholders, creating a sustainable design framework. Pause here to answer. And the answer is identifying and involving key project stakeholders. This is another question that's all about the keywords, which are initial phase of a project and stakeholder engagement. And this is a question where multiple answers could be right, so you have to go with which answer best addresses the question. During the early stages of a project, like programming and schematic design, communicating with and engaging stakeholders is super important. It helps in understanding their needs, expectations, and concerns, thereby enabling better decision-making throughout the project. Stakeholders can include clients, users, regulatory bodies, community representatives, and others who have a vested interest in the project's outcome. Conducting a detailed site analysis is important but primarily focuses on understanding the physical attributes of the location, not specifically on stakeholder engagement. Establishing a realistic project schedule is crucial, and the stakeholders are going to want to know what that schedule is, but it does not directly address stakeholder engagement and is not the best option provided. Developing a comprehensive cost estimation typically does not happen in the initial phase of a project and does not directly relate to stakeholder engagement. Creating a sustainable design framework will also be important to stakeholders, but it does not directly involve them and is not the best option provided. Now on to project planning. Which of the following factors is most crucial in determining a site's constructability for a new commercial building? Proximity to public transportation, availability of surrounding green spaces, soil quality and stability, architectural style of neighboring buildings. Pause to answer. The correct answer is soil quality and stability. Another question this week that comes down to the wording of the question. This one is asking specifically about constructability. Proximity to public transportation, availability of green spaces, and the appearance of adjacent buildings are important for an architect to consider. but they do not specifically address constructability. Soil quality and stability are critical in site selection for a commercial building. The structural integrity and stability of a building relies significantly on the condition of the soil beneath it. Soil assessments help the architects and engineers understand if the ground can support the weight of the building, the foundation type needed, and potential risks such as settlement or soil liquefaction during seismic events. So, what does this look like in practice? Well, I had a project recently where the client had a very large piece of land, about 40 acres, and we were assessing where to place the building on the site. So we took a look at the geotechnical report and soil samples and discovered that half of the site had unsuitable soils, which are soils that are very wet, soft, loose, and high in organic content. So we could not place the building on that side of the site without the client spending a bunch of money on removing and replacing dirt. This is why soil quality and stability is super important when it comes to the constructability of a new building. A brief pause here to remind you that I post new questions every week, so please hit that subscribe button to make sure you don't miss out on a video. It also really helps me out, so thank you. Now on to project development. When designing electrical systems for a commercial building, what calculation method is most commonly used to determine the minimum size of the electrical service required for the facility? Load factor analysis, voltage drop calculations, demand load calculations, or fault current analysis? Pause to answer. And the correct answer is demand load calculations. Demand load calculations are commonly used in electrical system design to determine the minimum size of electrical service required for a building or facility. By analyzing the expected loads from lighting, HVAC systems, appliances, machinery, and other electrical equipment, engineers can estimate the demand that the electrical system will face during normal day-to-day operation. This information helps in sizing the electrical service adequately to meet the building's electrical needs without overloading the system. While demand load calculations look for the minimum electrical service needed, there's also peak demand load that looks for if everything in the building was powered all at once. So that would be the maximum service size the building would need. Load factor analysis involves assessing the ratio of average power demand to maximum demand, which aids in understanding power usage patterns. Voltage drop calculations focus on ensuring that the voltage delivered to the end of the circuit remains within acceptable limits, considering the length of the wire and the current flow. Fault current analysis deals with evaluating the potential short circuit current that a system can deliver, which is crucial for safety and protection devices, but is not directly related to sizing the electrical service for demand. Next up is construction evaluation. Which type of mortar joint provides the strongest bond between masonry units and offers improved resistance against water penetration? Concave joint, V-joint, raked joint, or weathered joint? Pause to answer. And the answer is concave joint. A concave joint is also known as a bucket-handled joint. It's formed by shaping the mortar in a concave or rounded profile between the masonry units. The contractor does this by using a specialized tool that is pressed against the mortar while it's still malleable, which is only for 2 hours, so they have to do it quickly. Some advantages with concave joints are strength, water resistance, and durability. The concave shape of the joint allows for better compaction of the mortar, creating a strong mechanical bond between the masonry units, which enhances the structural integrity of the wall. The curved shape also helps direct water away from the wall's interior. The concave form sheds water more effectively than other joint types, reducing the chances of water infiltration into the wall assembly. This joint style is also one of the most durable, as it tends to resist weathering and erosion better than some other types, contributing to long-term durability of the masonry. Here are a few other joint types. Many of these are not often used today, but you may come across them in some preservation or restoration projects. The joint types from our question are in purple. And first up is the V-joint. These joints have a triangular shape and they look like the letter V, which is very easy to remember. While they can provide a decorative appearance, they don't offer as much resistance to water penetration as concave joints. Their angular shape does not effectively shed water away from the wall, potentially allowing water to accumulate within the joint. Weather joints are slightly sloped to allow water to run off the joint. While they can assist with water shedding to some extent, they do not provide the same strength and bonding or as effective water resistance as concave joints. Their slope design does not offer optimal protection against water penetration compared to the curved profile of a concave joint. Rake joints are formed by recessing the mortar joint slightly. While they can provide a unique appearance, their design doesn't typically offer the same level of water resistance as concave joints. The recessed nature of the joint makes it more susceptible to water accumulation. The key distinction is that the concave joint's curved profile and its ability to compact the mortar effectively provides a stronger bond between masonry units and better resistance against water penetration, making it a preferred choice both structurally and for water management. Last but not least, our bonus question is, which of the following materials is commonly used in finished carpentry to create decorative moldings and trim due to its versatility and ease of shaping? Oak, pine, maple, or mahogany? Pause here to answer. And the answer is pine. This question is primarily asking if you know your softwoods from your hardwoods. Pine is a softwood that is readily available and affordable. It's relatively easy to work with using carpentry tools, making it versatile for creating various profiles and designs for moldings and trim. Its softness allows for easier cutting, shaping, and milling compared to harder woods like oak or mahogany. It can be easily routed, sawn, and milled to create intricate designs and profiles for decorative elements. It also accepts stains and finishes well, allowing for a range of color options to match different design aesthetics. It can be stained or painted to achieve desired looks, making it a popular choice for finished carpentry where finish matters. While hardwoods like oak, maple, and mahogany are also used for finished carpentry for their durability and distinct appearances, pine's affordability, ease of working, and versatility in creating various decorative elements make it a preferred choice for molding and trim in many construction projects. Oak is a hardwood known for its durability and strength. While it's commonly used in various woodworking applications including furniture and flooring, it's not frequently used for decorative moldings and trims due to its hardness. Oak can be more challenging to shape and mill compared to softer woods like pine, making it less ideal for intricate decorative details that are common in finished carpentry. Maple is another hardwood known for its strength and durability. Like oak, it's less commonly used for decorative moldings and trims due to its hardness and tendency to be more difficult to shape compared to softer woods like pine. While maple can provide a beautiful finish, its hardness makes it less practical for intricate molding work. Mahogany is a hardwood valued for its rich color and grain patterns. It's often used in high-end furniture and cabinetry due to its aesthetic appeal and durability. However, mahogany is more expensive than pine and may not be as commonly used in finished carpentry for moldings and trim due to the cost and its density, which can make it more challenging to work with and shape. While all of these woods have their merits and are used in various woodworking applications, pine's affordability, ease of shaping, and versatility in creating intricate decorative elements make it a preferred choice, specifically for creating moldings and trim in finished carpentry. That's our questions for this week. Remember to check out the description for a list of some of my favorite study books. Let me know in the comments what subject areas you're struggling with, and I'll do my best to cover it in the next video. Thank you all for joining. Please subscribe, and good luck on your next exam. You got this.